Hello everyone, can you hear me? Yeah? Okay, good, because I don't hear me. So, my name is Anton, and as I was just introduced, I'm pretty active in open source communities and when it comes to Terraform. For the last 4 years, I've been doing pretty active development on Terraform community modules, Terraform AWS modules, and I'm trying to be as active as possible so that every time when you are working with Terraform in conjunction with AWS, you should stumble upon at some point of time code, blog posts, different tools and so on, which I put my hands on. I really enjoy this, and in spare time, when I'm not doing open source, I'm organizing and talking in different meetups, HashiCorp user groups, AWS user groups, DevOps Norway, DevOps Days, Oslo, I'm organizing as well. So a few projects listed on this page are related to Terraform, and some of them I will cover to more degree during this talk. And if you are curious about Terraform best practices or Terragrunt different approaches or reference architectures, I encourage you to check out these repositories. And don't hesitate to follow me on Twitter and GitHub, because I'm only working with Terraform, and I will be glad to help you if you need. So other than doing free open source work, I also do some paid work, because open source, as we may imagine, doesn't pay enough, right? I mean, who work with open source can probably guess that it's pretty hard to live on open source primarily. So I provide consultants, services, workshops, trainings, mentorship, code reviews, and so on. Again, most of this is related to AWS and Terraform. And one of my projects, which I started about a year ago, is Modules TF, where I take these reusable modules which I created over the last 3 years, which were downloaded actually more than 3 million of times for AWS infrastructure like VPC, autoscaling group, and so on. And using this visual tool to visualize your AWS infrastructure, who is, by the way, sponsoring my time here right now. So I would really encourage you to tweet this and say that, hey, Cloudcraft, you're awesome because you brought me here. So this is a project which is allowing us to visualize AWS infrastructure and convert it, not convert it, but connect it together and embed different relations, specify different properties, embed into Wiki, and so on. Everything is happening in the browser. But as you may imagine that we are in a conference which is called the Open Source Data Center, where things should not be so visual, right? So we have to treat everything as code. Infrastructure as code itself makes DevOps possible. So if we have been treating application as code and we take it as granted, we also have to treat infrastructure as code, because we need to know what has changed, or who has changed, or when it was changed. And we also need to put it in the same pipeline or similar pipeline so that we can actually validate changes before deployment it on production with fingers crossed mode. And if we are talking about what kind of tools are out there, the main tool which associate with infrastructure as code or infrastructure management is Terraform, which was started in 2014 with an idea of making it possible to build and change and version infrastructure in predictable way. So there are no surprises that something is going to be destroyed without you knowing it. So you always know what is going to happen. And Terraform was started with this concept back in 2014. So let me ask a few questions over this talk. And the first question is, when you look on this file, who doesn't understand what is going on here? Raise your hand if you don't understand what is this like. Okay, then I assume that all of you guys know basics of Terraform, right? So this is content of the file which has extension TF, and Terraform describes infrastructure in text file. Okay, so we can declare some variable like AWS region, and then we specify what kind of resources we want to make. In this example, we are making S3 bucket with random name. Then we run Terraform init to download some dependencies like providers. Then we run Terraform apply to let Terraform to calculate the graph and tell us what exactly is going to happen. In this example, Terraform is going to tell us that S3 bucket will have to be created, and we are confirming it with yes, and then Terraform is talking to AWS SDK or through SDK to AWS endpoint and produce an output that this bucket has been successfully created. So this is all what Terraform was designed to do, more or less. If you're looking from a public cloud provider perspective, you may think that AWS has already a CloudFormation, and they started it back in the days earlier than Terraform. And the idea was that there are resources, and people have to manage them in predictable way, not just by literally automating through Selenium, but through the code, okay? And they come up with AWS CloudFormation. And then Google figured out that they also have some infrastructure resources, but since Google is really developer-oriented company, then Python combining with Jinja should be probably a good idea, so that's why Google Cloud Deployment Manager started. And Azure said that there is nothing wrong with just JSON, so here you are, Azure Resource Manager. So these three technologies are most well-known for managing its own infrastructure there. But then there is Terraform, which is combining possibility to manage infrastructure on all of these three public cloud providers, but also more than 100 other providers. And the main benefit of using Terraform versus CloudFormation or Azure or Google Cloud Deployment Manager is that built in Terraform, there are features which allows us to have compositions, and they have native support for code reuse through modules. And there are also built-in tooling around Terraform, which allows us to separate planning from the execution, like dry run, and validation of what's going to happen in advance. So it is possible to script this much easier. If you know that Terraform was designed to manage public cloud resources, then I have bad news for you. It was also designed to manage Minecraft scenes and ordering Domino Pizza, right? I mean, you all knew this, right? That if you have an API endpoint, then Terraform can help you with talking to that endpoint. So Domino turned out to be one of the most recent examples how Terraform can be used to order pizza. And Minecraft is also having a REST endpoint, so why not build all these scenes in Minecraft through HCL? I think it's a good idea. What can possibly go wrong? So there are many different types of providers, and some of them are official, which means that you can actually rely on them and don't have to worry about forward compatibilities with upcoming version of Terraform. But there are also a lot of them you can find on GitHub or internally different companies, where unfortunately you will have to maintain that it's actually compatible with latest version. So let's start with something more or less real. Let's start in with managing AWS network stack. So this is an example where we tell Terraform that we want to make a resource in AWS VPC with specified CIDR block. Then we say that we also want to add internet gateway to it. Okay, pretty common, right? Then we tell that we need to specify a couple subnets there, and then we need to output these IDs, And then we actually have to add some NOT gateways because we are talking about more or less real infrastructure. So we are adding NOT gateways, routes, routing table, and few other type of resources which just basic network is requiring. So our configuration or main TF file for the network infrastructure will become 10 to 20 kilobytes of code if we are talking just about configuring basic things for the network. Okay, and 300 lines of code is not uncommon. So quite obviously, we will see that code size is increasing and dependencies become not so straightforward pretty soon. And when it comes to Terraform, Terraform has very few concepts which are absolutely unique to Terraform. And one of this concept which is known as Terraform modules, which is itself just self-contained package of Terraform configuration, or speaking it differently, is collection of TF files in one folder. So this is all what Terraform modules are. There are a few types of Terraform modules. And it's really important to differentiate them so that you can become more productive and you can use Terraform more effectively. The first type is resource modules. And resource module is usually a great candidate to be open source because it doesn't contain anything what is limited by your company. So it doesn't contain any secrets, any hard-coded values. It is absolutely reusable in your project A, B, C, company A, B, C, and so on. So this is an example of how we invoke resource modules. So we specify where these modules should be coming from. In this case, it's coming from Terraform registry. And we specify which version we want, and we also specify what kind of arguments these modules should accept. So I have another question for you. Would you use Terraform module to manage AWS EC2 security group? Or not? Or would you just write it in plain Terraform? Like plain Terraform means that you write two resources. One is AWS security group, and second is AWS security group rule. And you can have large amount of rules assigned to one security group. So for security group, you may think that it's probably a good idea to just write security group and attach few group rules, and it should be fine, right? So this is, if you look in this source code, you may see that it's maybe not so straightforward to understand what's going on. It looks green and yellow, but still it makes sense. And the big thing here is that this much more than 255, but approximately 600 lines of code is a source of reusable AWS security group module, which is the most popular module out there right now. It was downloaded 1.5 million of time over 2 years. So people are really relying on this code. And the benefit of using this module is that if you are willing to just use something existing and don't want to become an expert in Terraform, in AWS, in internals of AWS, in limitations of Terraform, specific versions, in bugs in providers and so on, you have to use something what is developed by someone else because it was simply tested. And it was tested in very many crazy setups. So I think that after you look at this 254 lines of code, you think that, oh my God, I don't want to write this piece of code. If I want to manage just security group, I will probably use something existing. So hopefully, yes. Second one is infrastructure modules. They consist of something smaller, like resource modules or individual resources. And this is a great place for your company to be creative and actually implement what makes sense for your company needs. Like you can enforce encryption or some other company naming standards, for example. And you can also use different preprocessor, JSON, and cookie cutter to fulfill the missing bits of Terraform providers or Terraform features itself. So this is the most important part in your infrastructure or in your Terraform activities, which you should be doing. So you really know what exactly you're going to develop, and you write infrastructure modules for that. So infrastructure modules invocation looks very similar. We specify where we want it to get from, and we specify different arguments which we pass into this module. Very similar. Inside of infrastructure module, we are invoking several resource modules of specific versions. This is very straightforward, I think. Few things which I'd like to talk about what to do with Terraform modules and what don't do there. And this is something what I experience extremely often. I deal with Terraform modules almost full time for the last 3 years, and I see a lot of code which people write inside of their project, and they want to expose it to another project in the same company, or they think that they are solving pretty big problem and they want to share it with the rest of community, and then they are asking like why my module is not used, but there are hundreds of forks. Yes, this is the main problem. There are hundreds of forks of your module is primarily because people cannot use it. They use it as for some cases, people reference to my modules, thank you for inspiration, they say to me. So they cannot use some of my code, but they thanks for inspiration. So it still counts. So this piece of code, if you put into Terraform modules, unfortunately is not going to be reused. So despite the fact that region is not variable, line 4 contains assumption that users of this module will be calling assume role. And since it's not possible to override the whole provider block, they will have to just fork this module, remove this piece, and the best practice for providers is to not put them into the module, but put provider's configuration on the high level, somewhere close to the root module, so that your module, in fact, should not have this block at all if you want it to be reusable outside of your personal machine. For example, if Vasya preferred to use default configuration, then he used the top configuration, while Petya may like shared credentials file, so he will configure it differently. And if you enforce them to use assume role, then none of them can use your code. This is absolutely the top frequent problem which I see in other people's code. Another evil part in Terraform modules, which people not always understand that this is exactly the limitation, is by using too much provisioners. So provisioners like local exec in this case will execute AWS CLI once AWS VPC resource is created. In many cases, this is not going to be possible to extend. For example, if we use AWS instance and we want to call Ansible playbook when this instance is started, it's maybe a good idea for a very short time. You will think that, yes, you're putting it in the right place. But then you figure out that this local exec block is not possible to use if you are using, let's say, auto-scaling group. Because in auto-scaling group, the triggering is created by launch configuration. So your launch configuration user data is a place where you have to put this kind of information. And always try to put or use cloud init facilities other than using provisioners, because they connect your machine where Terraform is executed with infrastructure. That's usually a very bad idea. If you still need to use provisioners to execute AWS CLI to add missing features to provider or to add missing integrations, then you may use special type of resource which is called null resource. So null resource is special because it is null. It's not real resource. It's just something what doesn't physically exist anywhere. Not in file, not on cloud provider, nowhere. And this piece of code tells that once VPC is created, then execute AWS CLI and do something. If we look into, in general, what are the common traits, as I call them, of Terraform modules, we will see that good modules, they are always started with good documentation and examples. It doesn't matter what kind of features are there. They're not going to be discovered anyway, right? Or how nice code is, or how short the code is, or did you put all the logic which you think you should be put in there. If there are no examples how people can easily execute it, and execution of example is always, again, without any kind of hesitation, should be the easiest things ever, so that you go to the example folder and you execute Terraform init, Terraform plan, and Terraform apply, and then Terraform destroy without any single parameter specified other than that. So I put this in the order of importance. So once you have documentation and example, you should have pretty good feature set, so that this module is not solving just your problem, but also more generic use cases, and so on. And I put test on the very end here, because I still don't believe in existing ecosystem or infrastructure testing tools like TerraTest or Inspect or Upspec. They're good for some cases, but I don't believe that they will give enough value added comparing to 4 other things at the top. They're totally different, and maybe we'll talk about this next year. But right now it's just a bit too early, and I'm not a big fan of any publicly available solution right there. If you have any ideas, I will be really glad to hear from you. So, are Terraform modules enough? Probably no, because, I mean, yes, everything starts with figuring out what is the reusable thing, and then we go from there. But it is definitely just the beginning. Let's look into how to structure Terraform configurations and how to call them. So when we are seeing usage of Terraform modules, because amount of code and resources is just increasing, okay, we figure out that now we have to group them somehow. But what about invoking these modules? How should we call them? Like, should we call them all in one, or should we put them in like a TF file and then put module after module after module? This is one pattern. The bad side there is that we are now exposing pretty large blast radius. So any small change which we do in some small thing may affect something totally bad. It can be very long time to execute, like 10-15 minutes is not uncommon. And also we will block everyone else. So blocking everyone else in the team mean that we have to use Slack much more, and now we have to talk on Slack to somebody and say, hey, don't touch this one because I'm changing this one. Have you finished this one because I'm going to touch another one, and so on. So if you are not big fan of using Slack for this kind of discussion, then keep in mind this. On another spectrum of way how we can organize Terraform code, there is one-in-one, where we have pretty granular invocation of modules. One module, for example, take care of VPC, and another one is taking care of ALB, but it has some trade-offs there. So the good part, obviously, is we are not going to be changing in totally wrong place. So if I have access to take care of my application because I'm a software developer, then it doesn't matter if I want or not, I simply will not be able to do any changes in VPC, which I share with 20 other developers. So this is really a good point. So which way you can imagine you group your code in your project? So just imagine or remember at your work, what kind of layout do you prefer? Like all-in-one or one-in-one? Can somebody raise hand and say all-in-one is what you use. All-in-one, half, okay. One person raised hand, not like this, but like this. It's half, right? So, okay, half. And who's using like one-in-one approach? Okay, so it's 5, 6 people more. Good. So I think the most frequent answer here is actually somewhere in between. Because when we don't know what's going to happen, like if it's new project, we always start with one file, we put whatever experiments we want, we invoke different modules there, we figure out, try different ideas, how things can be organized, and then when we get a clear picture about what's going to be needed, then we can migrate it into one-in-one. Or something very small, like, for example, resource modules, there is no need to use one-in-one approach and group them somehow. They're already small, so they're already tightly connected. So that's why all-in-one is good for them. But one-in-one, I think that it's really a good approach when we already know what are we going to develop, when we have pretty clear understanding or existing code base, where we know that this is our project number 10, and from the past I had been setting up VPC, auto-scaling group, and other things, then I can just replicate the same structure much easier in one-in-one. And I can also work interactively in one-in-one layout and allocate permissions to different types of developers. And when we have different types of developers, I want you to think about this as a totally distinct type or expertise of developers. Because not everyone in this room are full stack sysadmins, including Angular and Java and some other tools, right? So we have some qualification, some better understanding in networking, while someone else know, let's say, how to write business logic and Java and understand all these trade-offs in their business domain. So what about Terraform Workspaces? So who likes to use Terraform Workspaces? Cool, 2 people, wow, that's amazing. I don't like to use Workspaces because there are so many problems with them. So a few problems related to Workspaces are pretty fundamental. The infrastructure as code friendliness, as I call it, is one of the most important thing out there. Otherwise, we can still automate Selenium, right? We can still call Selenium to click in forms and fill in all fields and click buttons by their positions or XPath. No, it's not right. So infrastructure as code means that we should not execute code which we see in the repo. We should really be able to just read from specific place and get answers on how many workspaces do we have. What is the difference between workspaces X and workspaces Y? Without us being able to execute all interpolations and see if works or count equal workspace name equal prod, then 5, otherwise 10. Terraform had the concept of workspaces created for historical reasons back in the days. I would say it was a requirement for Terraform Enterprise. Normal people who don't use Terraform Enterprise can be pretty good without using it. So the only use case, if you, let's say, are familiar with Terraform for quite some time and you think that there is nothing else what I can do, or I have next 2 months free, so yes, then you can dive into Terraform Workspaces. You can invest some time, you can write some tooling about it, but the only use case where Terraform Workspaces make sense is for short-lived branch. So think about that you have GitHub pull request, and you want to spin up parts of your infrastructure every time when new pull request is open. So imagine the developer open pull request with some new feature. Then you have to spin up new service or ECS service or some sort of auto-scaling group. It doesn't matter what you use, but just for short-lived, for him to be able to test this feature. Then you click on that feature, you figure out that it works, and then you merge this pull request, right? So when this feature is merged, then you have to delete that workspace, and you're done. So that's the only situation when you can use Terraform Workspaces, is for short-lived branches. And if you think that, yeah, but Workspaces, I mean, I already wrote all of this code, and it works for me. At some point, you will probably realize that the same concept which we had before is called Terraform modules is much better than Workspaces. Again, the idea is that you don't hide the code behind of some statements or some conditions and so on. You have this infrastructure, then you have this configuration as file laying in known place. So we are not paying for disk storage anymore. It's okay to copy 5 kilobytes file, put it into known location, and then I always know that, yes, this is a workspace equivalent. So who knows about Terraform 0.12? Like, who's overexcited? Cool, cool. So some people raise hand and then drop it because maybe you're not so excited. No, actually, Terraform 0.12 is one of the biggest releases which is coming out pretty nicely and soon. And you may think that Terraform 0.12 has been totally rewritten, and in fact it was, because there are a lot of features implemented, especially if you're coming from general purpose programming. You will think that, oh my God, finally, there are loops, there are like dynamic blocks, there are correct condition operations where left and right parts are not executed simultaneously. And there are many, many other cool features which you was always dreaming about. And finally, Terraform 0.12 will have all of this, right? So who think about this like I just explained? Right, so there are people who think that Terraform 0.12 is going to be absolutely cool exactly for these features. So simplified syntax alone means that we don't have to end quote with double quotes, dollar, curly sign, curly bracket sign, and so on. So, but the thing which I just want to kind of try to ask critically is like, will everything be all right after 0.12 coming out? Let's say it will come up, I don't know, in 1 month. Because a few days ago there was release candidate 1, then there will be release candidate 2, and then there will be final 0.12.0. So will there be any changes? Or like, let's say on Monday I come back to work and I open computer, download latest version, execute migration script which will convert previous syntax into new syntax, which is realistic. It will convert syntax because syntax is backward compatible. This is partially why it took so long time. So it will be converting all of my syntax, and now my Terraform will be using 0.12, right? So I have some good news and some bad news for you. So as I said earlier, there are 2 types of Terraform users. So the first type of user is Terraform developers. And one of the best practice which I really want to kind of to make it clear is that there are no full stack developers for Terraform. Even if we want everybody to be convinced that Terraform is easy tool, that you can just write TF files and then it will magically create these resources for you. You see how it's easy. There are a lot of things which we still have to know. For example, we have to know public cloud domain. We have to understand networking internally. We have to understand Terraform syntaxes, and we have to understand in general everything what typical DevOps engineer is doing. So what we do during our work is that we consuming a lot of information. We become domain experts in that, right? So we know how to use Terraform in a way that we can make something what can be consumed by other people. And inside of company, very good pattern is that so-called DevOps engineers, I like them to be so-called, because we all know that it's not just about tools. So-called DevOps engineers are implementing and maintaining reference architectures for the parts which they have. So, for example, if you're dealing with your, let's say, domain-specific, if you are dealing with something inside your company, then it will be a pretty good idea to implement common practices and establish common solutions. Okay, so this is where your expertise will be needed as DevOps engineers. And on the other side, another group of people, which is usually a very big group of people, is somebody who can really just use whatever is created by your team or by other people. So I usually put them as like Terraform users. So the idea is that Terraform is so easier to use that a lot of people will just say that, oh yeah, I know how to use Terraform. Yes, you do, but will it be a pleasure to use your code after half year? Or maybe if you quit, nobody will understand why you did this way. It's a common problem as with many other technologies we're using, right? And the cool part is that in order to use Terraform, you don't have to have Terraform in your LinkedIn profile, right? You can hire more people. So I think it's achievement. So Terraform 0.12 for developers will allow to use all of these awesome features, for loops, dynamic blocks, and so on. But what I want to understand and what I want to make sure that a lot of people understand is that this is not for everyone. Your end users don't really care if you specify or if you use for loops finally, if your Terraform code now is 20 lines smaller or longer. They absolutely don't care. The only thing which they want to care is that they can use this Terraform solution which you make in order to spin up what they need. It can be S3 bucket, okay? But it has to be S3 bucket according to your company standards, naming, tagging, encryption, and so on. And Terraform 0.12 has a lot of this for developers. While for users, I would say that the only benefit which users will gain is that, yes, they don't have to remember or become familiar with all of these interpolation syntaxes and double quotes, and everything can be lists but not maps, and so on. Conversion between types. Yes, this will be very much simplified, simply because it's rewritten from scratch. And as a summary of this, I want to tell a few things. Again, Terraform modules is just must-have. I cannot emphasize this more because there is nothing else. You cannot reuse one resource floating around. Or if you already know what you're going to do and how you structure your code, then Terragrunt is a tool which can be used to orchestrate invocation of infrastructure modules. And one-in-one approach gives you much, much better life over time. Terraform Workspaces is not good because we're not paying for disk storage and we don't need to execute all of this logic in our head anytime. And 0.12 is beneficial primarily for Terraform developers. And in many companies, at least where I work, I see a lot of people who may learn Terraform, but I really don't want them to learn Terraform. I mean, if you're a front-end developer with Angular experience, why on earth you should learn Terraform? Yes, you will become cool, but that's not giving any benefit to the company. Or you can think that you will be better doing your Angular work or Terraform, probably Angular. So for me, that's it. Do we have a question? Yeah, we have time for questions. Yeah.
Just a second. I have a question regarding the new configuration language in Terraform 0.12. Do you think that with Terraform 0.12 we can finally get rid of this whole count equals 0 mess? Or do we still have to use it?
Yeah, count equals 0 will unfortunately still be needed for...
There's still no if-else.
No, there is no if-else.
For loops, but no if-else.
No, there is no solution for that at all. But I'm not sure if I understand why you're so afraid of this. Like, yes, this is one of meta argument which we have to specify. Maybe it doesn't look so nice, but if you hide it from your users and if you keep it for your Terraform developers to, let's say, replace it, it can be replaced. Usually it's replaced with variable which is called create underscore VPC equal true. And then if it is, I mean, it makes sense for your users, right? And then internally you can use it. If it was true, then create this bunch of resources. So no, there is no plan to do this as far as I know. And very few people actually complain about this because maybe they get used to it. No, I mean, people get used to it. They kind of...
Great talk. Hey, I wanted to ask you about Terraform Enterprise. I know you said, I think you said for normal people not using Terraform Enterprise. So I'm one of the abnormal people that is using Terraform Enterprise. I'm curious, I guess first, why is it not mentioned in your talk? And then do you recommend it? Or should, we have a team of like 5 people that are managing our little section of infrastructure. Do we really need Terraform Enterprise for that?
Yeah, that's a really good question. So the reason why I didn't mention anything about Terraform Enterprise, first reason, I'm not affiliated with HashiCorp. They didn't pay me to talk about how awesome Enterprise is. And second is, Terraform Enterprise is not awesome. So it is not awesome because there are a bunch of things which you can get from open source to combine your own enterprise features the way you want them. For example, Atlantis. Atlantis alone is a tool which can be connected to your version control system and listen to pull requests and execute Terraform in central place and submit comments containing Terraform plan to this pull request so that everybody know what exactly is going to be executed and they can confirm or they can deny pull requests. So this is like 50% of what Terraform Enterprise has. Another downside which I observe as Terraform Enterprise people telling me is that it's pretty hard to jump off from it. So yes, if you start using all of these workspace related features to the way how they're implemented in Terraform Enterprise, you cannot just easily use free version. Yes, you will be able to do this, but you will have to write tons of shell script to orchestrate or to replace all of that workspace magic. And this is one thing which is pretty hard. And third point why Terraform Enterprise can be usually used wrongly is that there is Terragrunt. Terragrunt is a tool which allows you to use small reusable pieces the way you want. So you have your modules, your Terraform modules, you group them the way you want, and you go to the, let's say, root folder of this, and you run Terragrunt apply all. And then it will go through the whole tree of your dependencies and then execute resources or create resources step by step. So VPC will be first, then something else, and so on. So this is one of the cool features which you can get for free. So overall, I think Terraform Enterprise, which costs several $1,000s, is not worth it if you are 5 people. If you are a big company with lots of money, then maybe yes. I mean, not maybe, but definitely yes. Otherwise, HashiCorp wouldn't exist. So yes, they pay it and they get good support. But for small companies like me, where it's from 1 to 10 people, it's usually much easier to get project like Citizen, to have your own Terraform registry hosted, combine it with Atlantis, combine it with Terragrunt. Some of these things I put into Terragrunt reference architecture, where I combine all of this and I show how it's done. The missing part right now is UI. So there is no UI, like centralized UI, where you can give people access or make sure that you have overview of your whole infrastructure. So then you have to bring on board project like Terraboard to investigate your TF states and so on. So yes, as always, if you want to use something free, you can do this, but you will have to pay some money to glue all these things together.
Thanks again, Anton.
Thank you.